All right, welcome to Getting Ready to Solve Equations. I have a set of basic rules of math that all of math boils down to just a couple of important rules. And the first couple are that identity rules really matter. And so if you add or subtract 0, nothing happens. It's just the same thing. If you multiply or divide by 1, again, nothing happens. It's just the same thing. And that multiplying by 1 we use all the time because I can cleverly make 8x squared times y over 8x squared times y. That's equal to 1. So I can use that to cancel lots of things in my math life. And that actually leads into the second part here, which is that inverses are super important. So when you have two sides of an equation and you're trying to get rid of a plus 4, and so you subtract 4, you do minus 4, what you're actually doing is taking the inverse. You want to do the inverse of that plus 4, and that's subtracting. Same thing with multiplying. If you have a 2x equals something, so you divide both sides by 2, what you're actually doing is taking the inverse of multiplication or dividing. And through adding, subtracting, multiplying, and dividing, it's not very important and usually not emphasized to call it an inverse. But as you get into higher math where you have functions like exponents and logs and sines and cosines, you're really going to be doing all the same things you were doing in earlier algebra, but it's harder because now you have to use a function to take an inverse. And so I want to start using the language of taking inverses, and that's why one of my important sets of rules. Equations. You can do just about anything to an equation as long as you do the same thing to both sides. So just never forget to do the same thing to both sides and never, ever divide by 0. All right, so the first thing I want to do is just look at a couple of examples of what are the additive and multiplicative inverses for numbers. So the first one there is minus 8. So the additive inverse, what we have to do to get rid of it is add 8. The multiplicative inverse, and so we want to do with the multiplicative inverse is end up with a plus 1. So first I have to multiply it by a minus to get rid of the plus, and then I have to multiply it by 1/8. So minus 1/8 is the multiplicative inverse of minus 8. All right, so for plus 2/3, the additive inverse is just minus 2/3. The multiplicative inverse, I don't need a minus sign because I want to end up with a plus 1. I need to multiply by the flip of it. So if you have 2/3 times 3/2, that's going to equal 1. All right, so 6w, its additive inverse is minus 6w. If I have plus 6w and I subtract 6w, I'm going to get 0. The multiplicative inverse, again, is I want to multiply these two things together and end up with 1. So it's 1 over 6w. And finally, the square root of 10, the additive inverse, as you might guess, is going to be minus square root of 10. And multiplicative is going to be 1 over the square root of 10. So what you should notice here is for multiplicative, you basically flip and get the fraction that is the opposite of the original, and then you have to have a minus sign if you need to get rid of 1. And I added a little note here. There are also functional inverses, and I'm just pointing this out now. So for example, we're taking the square root of 10. The functional inverse of that would be squaring it. So the functional inverse of a square root is to square it. It doesn't get me back to 1, but it does get me back to sort of the most insular number, which is 10 there. So if I had a 10 and I took the square root of it and I want to get back to my number 10, then the functional inverse of that square root is a square. So that's an example of where we're going to go this year and also next year with higher order kinds of functions than the simple algebra ones we've been working with up till now.